Hello, today we're going to discuss experimental probability. Experimental probability is probability based on an experiment and is written like this. So probability of event, just like we do with theoretical probability, is the number of favorable outcomes like we see in theoretical, but instead of being the total number of outcomes, it's based on the total number of trials. And trials are the number of times an experiment is performed. So let's see what this would look like. It's very similar to theoretical. It's just based on what really happens as opposed to what we think or in theory what will happen. Tessa rolled a number cube 10 times. The number cube landed on the number 2 6 times. Write the experimental probability of landing on 2 based on her experiment. So let's highlight the information that was given. So the number of trials that she performed were 10 times. She rolled the number cube 10 times. She landed on the number 2 6 times. And it asked us to write the experimental probability of landing on 2. So we would start with the probability of the event we're looking for is landing on 2. And they mentioned she landed on 2 6 times, and the number of trials were 10 times. We could also reduce this and say the probability of landing on 2, her experiment, what it says was 3 out of 5 by dividing both of them by 2. So let's look at the second one, and then you'll try the third one on your own. Malik flipped a quarter 20 times. The quarter landed on tails 12 times. Write the experimental probability of landing on tails based on his experiment. And by the way, let me briefly go back to the one before. We could also write this as a percent. We could say the probability of landing on 2 was 60%, or we could say the probability of landing on 2 was 0.6%. We can write it in decimals, fractions, or percents. So let's get back to number 2. Malik flipped the quarter 20 times, so there are 20 trials. The quarter landed on tails 12 times. So write the experimental probability of landing on tails based on his experiment. So we would put the probability, and the event we're looking for is tails. And it said that he landed on tails 12 times and he had 20 trials. Again, we could divide this by 4, both top and bottom number, and so we could say that the probability is 3 again out of 5. That's just a fluke. It was the same thing. And if you're not sure how I converted this, we take 3 divided by 5, and that's where the decimal would come from. And then if we wanted to write that, excuse me, as a percent, we would multiply by 100 to get 60%. So would you please try number 3 and number 4 on your own, and then look back at the answers. For number 3, the event was hitting a bullseye, and when the experiment occurred, it happened 8 times out of 50. So we start with that, and then we can reduce it to 4 out of 25 by dividing both of these by 2. And then to get this decimal, again, you take the top number divided by the bottom number, which leads to this decimal, and you multiply by 100 to get the percent. This next question was a little bit trickier. The 6-sided dice was rolled 24 times, and it landed on 2 4 times out of the 24. So 4 out of 24. And we can reduce that by dividing both of them by 4 to get 1/6. And unfortunately, when you take 1 divided by 6, you're going to get a repeating decimal. And they'd probably ask you to round that perhaps to the nearest tenth or the nearest hundredth. And if we converted that to a percent, we'd multiply this by 100 and get 16.6 repeating percent. Now again, it didn't give us permission to round, but we would probably be asked to round, different situation. So letter B was very different and it also mentioned 2 things. So this question had nothing to do with 6, but this one said not landing on 6. So the probability of landing on 6 was 3 times out of 24. So that meant that not landing on 6 would have to be 21 out of 24. And again, to get to the decimal, you take 21 divided by 24, And then to get to the percent, you need to multiply the decimal by 100. Let's go on to the next page. Amanda used a standard deck of 52 cards and selected a card at random. She recorded the suit of the card she picked and then replaced the card. This will become important when we have to work about dependent and independent events. The results are in the table below. So what happens if we pick a card and replace it? We're always going to have 52 cards in the deck. And if we don't replace it, that will change the probability, which we'll get to in another lesson. So diamonds occurred 7 times, hearts occurred 9 times, spades occurred 11 times, and clubs were 3. So that might be helpful if we write those tallies down. We have 7, we have 9, 11, and 3. So first question says, based on her results, what is the experimental probability of landing on a heart? So we're going to write the probability, and the event is heart, landing on a heart. And I see that that happened 9 times. But what I don't know is how many times she conducted the experiment. So in this situation, you would add all of these numbers, and the total of this looks like it's 30. So double check that for me, please. And so the probability would be 9 times, because it said hearts, out of 30. So she drew 30 times. And we could reduce that. 3 goes into both of these, and it reduces to 3/10, which would be 3/10 written as decimals, and that would also be 30%. The next question asks, what is the theoretical probability of selecting a heart? So this time, we're going to have to go back and not look at the table. We're going to have to think about how many hearts are in a deck of 52 cards. So if you're familiar with cards, there is the numbers 2 through 10. Then there's an ace, and then there's a jack, king, and queen. So that adds up to 13 cards. So 13 cards for each one of the suits. So we would, again, write the probability of landing on a heart. So we're still looking for that. But theoretically, it would be the number of hearts in the deck, which is 13. And this time, it's not based on an experiment. It's based on how many possible cards we can choose. And there's 52 in a deck. So you could reduce, 13 will go into both of these numbers evenly, and this would be reduced to 1/4, which is also 0 and 25 hundredths are 25% of the time. Third question, based on her results, what's the experimental probability of selecting a club? So again, this is based on the results. We're going to go back to the table, and I see 11 times she chose a club. So we're going to write that experimental probability. We're looking for a club this time. And that happened 11 times. And we've established the trials. She had 30 trials. She picked a card 30 times. And this cannot be reduced because 11 is prime. 11 goes into itself, but it will not, 30 is not divisible by 11. Would you please now look at the next 2 questions and then look back at the answers. For number 4, based on her experiment, again in the table, she drew a diamond 7 times or a spade 11 times, and those 2 add up to 18 times altogether out of 30. And both of those numbers can be reduced by 6. So we could also write it as 3 out of 5 times. And our last question is very similar, but it mentions theoretical probability, not experimental. So in the deck of cards, there are 13 diamonds, and there's also 13 spades. So we add those 2 up to get to 26, but instead of trials in an experiment, we have to think about how many cards are in the total deck. How many different outcomes could there be? Well, there's 52 cards in the deck. and that also can be reduced to 1/2. Thanks for listening, and have a great day.